Hello, good afternoon everyone. My name is Mohsin Mullah and I am lab in charge of Power Electronics and Network Analysis Laboratory. So this laboratory is having a total area of 79 square meter. So as per AICTE we need only 66 square meters. So we have sufficiently large uh, here carpet area available for us. And in this laboratory, three courses are run every year. So we have got Network Analysis Laboratory as well as Power Electronics Laboratory and Electric Drives Laboratory. So right now in the E1 semester we have Power Electronics Laboratory. Okay, and also in this laboratory premises we have displayed our vision and mission statement as well as program educational statement. Okay, and also here we can see that the information regarding the contact number of the lab in charge, technical assistant, as well as the total investment in this particular laboratory is around about 4,12,250 rupees. And here is the list of some major equipments that we have in our laboratory. So here you can see the description of each of the major equipment, as well as here we can also see the cost of each of the major equipment. Okay, so now currently here Power Electronics Laboratory is running. So let us see the list of experiments here. So in the odd semester network analysis lab will be running here. So that time we have got these all experiments which can be conducted in this laboratory, as well as for this even semester we have got Power Electronics Laboratory. So here is the list of various experiments of the Power Electronics Laboratory. So currently we are conducting the first experiment, that is to study gate drive circuit in the Power Electronics Laboratory. So here we can see the write-up of the same, this experiment number 1, study of gate drive circuit. Okay, so here what is the aim of this experiment is to study the gate drive circuit of IGBT. Okay, so now here we can see the apparatus required for that, for the conduction of that experiment. So here we are going to use the power electronic module of SCR MOSFET IGBT characteristics module. Okay, and then we are going to use one multimeter to measure the current, as well as we are going to use some connecting wires. And this is the circuit diagram of the IGBT. Okay, to study the gate drive circuit. So here this particular device works as an electronic switch. So this side we are connecting the load. Okay, so this side represents the load. Okay, so in the load, suppose we want to have certain amount of load connected here, and the current we want to make to flow through that particular load, then the switch needs to be closed, then only the current will be flowing. So here as a test we are going to connect 1 kilo ohm load. Okay, so through this 1 kilo ohm load current needs to be flown. So that current will be flowing when the switch is closed. So to close the switch here, so we need to apply gate voltage. Okay, because it is an electronic device and it is insulated gate bipolar transistor, so it works on the principle of field effect transistor. Okay, so therefore whenever there is a gate voltage applied at this terminal, so the gap between this collector and emitter terminal will be bridged with the help of electrons. Okay, so therefore the switch will be closed and the supply will be connected from this positive terminal through the load and to the emitter back to the negative terminal of the supply. Okay, and we are going to measure the applied voltage here by using a voltmeter of the range 0 to 300 volt, and then we have got a multimeter to measure the current from the range between 0 to 200 milliampere. Okay, as well as this side to see the voltage applied to the gate terminal, we have got another voltmeter. So range of that voltmeter is 0 to 10 volt, and here we identify the voltage applied to the gate and emitter terminal as VGE, and the voltage applied to the collector and emitter terminal as VCE. Okay, so now to study this particular operation of this IGBT here, so we need to see two types of characteristics that can be obtained from this experiment here. So one is called as switching characteristics and second one is called as the transfer characteristics. So here in case of switching characteristics, what we are going to obtain is the instant at which the gate is going, that IGBT is going to get connected, or you can say that switch will be closed when we apply a particular amount of the voltage at the gate terminal. So that voltage is nothing but the threshold voltage. So you can see initially when we increase the voltage VGE, so that time initially there won't be any change in the current that is flowing in the circuit, because that time the switch is not closed. But as soon as we cross a particular value of the voltage, that time the current will start rising, so that indicates that switch is closed. Now to carry out those, to obtain those two particular, we can say, curves here, so what we need to do is we need to apply certain voltage called as VCE1 from the voltage source available at the VCE. Okay, so that voltage initially we are going to apply as 50 volt. Okay, and when we apply that voltage 50 volt, so that time there is application of the voltage, and unless and until the gate is closed, so the current is not going to flow. Now we are going to increase the value of the VGE. So here in the steps we are going to increase the value of VGE, and we will see that when we increase this value to say 2 volt, 3 volt, 4 volt, then 5 volt. So exactly at 5 or 5.1, so we'll see that there is change in the current. Okay, so here till this, so we are going to get 0, but suddenly here we are going to see this 0.7 or zero point 0.8 or 1 milliampere of the current. After that, when we increase the voltage, so that time the current is going to increase to say around about 30 milliampere, after which for every increase in the value, the current is going to remain constant. So what that indicates is that for the particular application of a VC voltage, okay, so only certain amount of current can flow. After that it will remain saturated. Okay, because there are we can say the applied potential difference is sufficient only to make 30 milliampere of current to flow through the circuit, not more than that. Now if you want to increase the value of that collector current IC, so what we need to do is we have to increase the applied pressure here, that is applied potential difference. So that time we are going to take another value VCE2, so we are going to keep this value as 100 volt. So when we apply 100 volt VCE, so again we are going to follow the steps. So we are going to increase the VG from 0 so on till it gets close, and after that when we see the second set of readings, so in that case, so what we will see that this value will become around about 75 milliampere. Okay, so almost like double we will get what we had got in the beginning. Okay, or with the 50 volt VC. Okay, so when we have 100 volt VC, so the current is going to increase to a particular value, and then after that again it is going to remain constant as the applied potential difference is sufficient only to make that 75 milliampere of current to flow through the circuit. Okay, so not more than that. Okay, so likewise we can repeat the same steps by changing the different values of VC, and for every value of VC we will be getting a curve, but one thing will be common in all those curves, that the threshold voltage will remain exactly the same. At that particular applied gate voltage, the device is going to switch on. Okay, and the current starts flowing. So that is what the switching characteristics is. Now next is the transfer characteristics. In case of a transfer characteristics, we are going to change VC. Okay, and we are going to see at what value the current or what particular value of the current we are going to obtain for different values of VG. Okay, so here we are going to take VG1, VG2, VG3, so on. Okay, so now here suppose I am going to apply VGE equal to exactly 5.1. Okay, I am going to keep that constant VG equal to 5.1. So what is going to happen is that, so there will be electrons available between collector and emitter, so there will be one we can say layer of electrons formed here, but limited electrons will be there, and when VC is increased, so current will start flowing as that VG is sufficient to make the IGBT to turn on, so the current is going to flow. But how much current will flow? It will depend upon what amount of electrons are available. How the electrons number will be decided? It will depend upon what amount of pressure is applied at the gate terminal. So if the applied pressure is only 5.1, so in that case the available electrons will be limited, and however we increase the VC voltage, those many electrons are only going to flow. So therefore here we can see that after a certain value the current is going to remain constant, IC value is going to remain constant. Now if you want higher value of current to flow here, so that time what we need to do is we have to increase this VGE to little bit higher value. So in the second case I can take this value. If I say this is 5.1, so this will be equal to for 5.2, and this is going to be equal to for 5.3. 3. So likewise we can take for different values of VGE. By varying VC we will be able to get the required that transfer characteristics. So from that we can understand that as we are going to apply the gate voltage here, so the saturation level of the that particular device is going to increase. Okay, so same way we are going to take the different readings here for different values of VGE, and steps of the same will be repeated for different values of VG, and by changing VC we can enter the values of IC here in terms of milliampere in the tabular column given. Okay, so now let us go to the table, so where we can actually see the conduction of the experiment. So now before we actually do the conduction, let us understand what are the objectives of this particular experiment. So basically this experiment is conducted to see that how electronic device can be also used as a switching device, and how exactly we are going to operate the that IGBT as a switch in the actual circuit. Okay, and what will be the outcome? So here the student, after learning this experiment, will be able to use the IGBT of different ratings in the different power electronic circuits to carry out different applications. So like IGBT can be used in the control of speed of the DC motor. Okay, so that time by controlling the voltage, so we can control the speed of the motor. Okay, so in various operations that IGBT can be used. Okay, so now let us see how we can make the connections of this particular setup here. So here you can see we have got two units in the that experimental setup. So first unit is for supplying the voltage required for VC as well as for gate. Okay, and second is the devices available here. So you can see there are number of devices available here. So first one is the upper terminal. So here when we see the IGBT particularly, so we have collector, we have emitter, and here we have got the gate terminal. Okay, so the supply will be connected from this module to this module. Okay, so let us do the connection. So from this positive terminal of the supply I'm going to connect, to make sure that this is 0 and this is 0, then we are going to make the connection. So this is going to be connected here. Okay, so then we are going to connect the positive of this to the gate. Okay, fine. Okay, so now here we need to measure the collector current. For that we have got the availability of the terminals to connect. So already there is inbuilt meter, but for our convenience we are going to use the digital milliammeter so that we can see the readings. Okay, so here we are going to insert this here so that that ammeter will be connected in series with the supply. So that other terminal is needed to be connected to the collector. So I'm going to connect this terminal here to the collector. So now the upper circuit is complete. On the lower circuit, so I'm going to connect it from this supply. So here one knob is given, so that can be used to connect to the any of the gate terminals of the various devices. So here we have got MOSFET as well, IGBT, then we have got the track, then we have got SCR also. So but here for our experiment we are going to use only IGBT module. So therefore I am going to connect it to IGBT. On the lower side I am going to connect to the emitter terminal. Okay, so here I have already made the junction of the two terminals because I need to connect to the negative terminal of both the sources, as the emitter is the common terminal here, that IGBT is having that emitter as the common terminal. So this negative is also connected. Okay, so now let us turn on the supply, and when what we need to do first is we need to obtain the switching characteristics of the IGBT. So therefore, as I told you, so initially we have to keep the collector emitter voltage to certain level, then we have to increase the VG VG, and at a particular value of VG the device is going to turn on. Okay, so let me just apply the voltage here. As I told you, first we'll keep the 50 volt VC, then I am going to increase VG slowly. Okay, so here, so at the same time we need to see the current reading as well as the voltage reading. So exactly at you can see here when I am below 5, so you can see the reading 0, but as I am increasing, the current is increasing slowly, and suddenly when I am going beyond 5.1, so you can see that suddenly here the current will increase. So that indicates the IGBT has now started to conduct. and when I'm going to increase this value, you'll see increase in the IGBT, that IC current. So I'm just going to increase the range. Okay, but after a particular value, it is going to remain constant. It is not going to change. Now I'm increasing VG, you can say 10, but still here it is constant 35. Okay, so that is what we will get. So one particular value of the voltage we are current we are going to get for a particular applied VC voltage. Now let us repeat with the other value of the VC. So now I'm going to keep 100 volt. So again I'm going to apply VG in the steps. So first 2 volt, then 3 volt, 4 volt, then again when I'm reaching 5, so you'll start seeing the change in the current, and suddenly when I go beyond that threshold voltage, so current will start increasing. So 5.1 is as the is identified as the threshold voltage at which the gate is going to turn on. So when I increase this value, you will see that the current is going to increase to 73, and even after that, if I increase the VG, I am going to get the constant value. So that indicates the device has been saturated and it is in the on condition. Okay, so this is what the switching characteristics is. Now next what we need to study is the transfer characteristics. So for that we are going to now apply the uh, that gate emitter voltage at which the device is going to turn on. So here that milliammeter will show us when it is going to turn on. So now it has been turned on. Okay, so okay, so little bit less. Okay, so now it has turned on, I can say. So now I'm going to increase the VC so that the current is going to increase. So increasing VC is not able to change the current, so it means that still it is not turned on totally. So I'm going to increase a little bit. Okay, so now let us see. So as I increase VC, so you'll see that current is going to increase. So 1.92, and after that it is going to remain constant. Okay, so that indicates that the device has become saturated. So even with the increase in the VC, it is not going to change. Same way we are going to increase this VG to little bit higher value. Okay, say 2.5. Okay, so at 2.5 if I increase this, okay, so you'll see that current is going to increase but it is going to remain constant. So at 3 it is going to remain constant. Okay, similarly if I increase it to say 3.5 or just 3. Okay, so now let us see. So we can see 4 point or 5. So one thing you will observe that if I keep this high voltage available, so what will happen? The current goes on increasing. It is because the device is getting heated, and as it gets heated, so the current will start increasing. So that is what you are observing. Otherwise, if I don't increase this voltage, it will remain constant. Okay, as you can see. So this is how you can obtain the transfer characteristics of the IGBT as well. So whatever steps we have followed, you just need to do it step by step and note down the reading. So like here directly I have increased, but you can take the reading at 20, you can take the reading at 50, you can take the reading at 100, etc. So you can go on increasing for different values, you will get the different readings. So you can plot the required graph. Okay, so this is how we can verify the gate drive circuit of IGBT. Okay, so I hope you understood the concept. Thank you.